Now, I will show you how to calculate the coefficient of permeability for variable head test method. This is for calculation for coefficient of permeability for variable head. One coefficient of permeability that equation for coefficient of permeability K will be equal to 2.303 A into L, this divided by A into T into log 10 of H1 minus H2, where small a is the cross sectional of the standpipe. I showed you earlier that what is standpipe, that A is cross section of standpipe, that is A, that will be equal to pi by 4 into d square, and that will be equal to VW divided by H1 minus H2. So, where small d is the diameter of standpipe and VW is the volume of water collected. Volume of water, this is collected, and L is the length of the mold. Length of the mold, and A is area of cross section of soil sample, and T is time in second, and H1 and the H2 is the initial and final head. I showed you the earlier one sketch that you can calculate that what is coefficient of the here. This is the standpipe. Okay. This cross section of the standpipe is small a, that is pi by 4 into d square, that means d is equal to diameter of this standpipe, and then water fall from initial height is h1, from here to here h1. So, initial height was here, then water fall at a particular time, then this position, that is from here at a height of h2. So, that is why h1 and h2 are the initial height and the final height, and here is the sample whose length is equal to L, that is L is equal to length of the mold, and this mold also has a cross section of this soil sample is capital A. This is capital A, this cross section of the soil sample, and at a particular time t, then you collect the sample water and then you measure that what will be the quantity of water you have collected, that is the volume of water, that is VW, volume of water is collected from here. Okay. So, then you can measure all these parameter, that what is H1 and what is H2, also at a particular time t, and what will be the quantity of water you have collected in terms of the volume. And you know that what will be the area of the mold and what will be the area of the standpipe. So, then you can calculate that what will be the coefficient of permeability of the soil. Next, I will show you some specimen calculation. Specimen calculation for variable head test. Okay. So, one is the soil sample detail, and that is, let us say soil is clay. Then you measure the molding moisture, let us say is 19%, and then you calculate the molding density. This is equal to 1.764 gram per cc. Now, you know what will be the length of the mold, length of mold. Length of mold is designated at L is equal to 6 centimeter, and you know what should be the diameter of mold. Diameter of mold is equal to 7.98 centimeter, is equal to 7.98 centimeter, and 6 volume of mold. Volume of mold. Volume of mold is equal to 300 cc. And then you know that area of cross section of the sample. Area of cross section of the sample, let us say A, is equal to 50 square centimeter. Now, also you should know what will be the area of cross section of standpipe, that is designated as small a, is equal to 0.6648 square centimeter. And then you should know that diameter of standpipe, and that is 9.2 millimeter. So, you know all this data, you know about the soil, that molding moisture content, molding density, length of the mold L, 6 centimeter, diameter of the mold 7.98 centimeter, volume of the mold 300 cc, area of cross section capital A is 50 square centimeter, area of cross section of standpipe small a, this is 0.6648 square centimeter, and the diameter of the standpipe 9.2 millimeter. So, knowing this all this data, so you can calculate that what will be the coefficient of permeability of the soil. I will show you about some specimen calculation. For variable head, for variable head test. So, you have to remember that equation, what will be the specific for the equation for coefficient of permeability for the variable head test method. Here let us say that for a particular serial number, you have to determine what should be the initial head, and that is designated at h1 centimeter. Then you take what will be the final head, and that is designated as h2 centimeter. So, you know that initial head, you know that what is the final head, then you know that elapsed time, that is let us say t in second, and then from the equation you can calculate what is log of h1 by h2, and then you can calculate the k coefficient of permeability in meter per second, and then you can calculate what will be the average k, that is meter per second. So, this is for a serial number 1 test. Okay. Let us say that initial head, that is h1, initial head, that is h1, here this initial head h1, let us say this head is for the serial number 1, this head is 50 centimeter, and the final head, this is h2. So, this h2 is let us say 46.5 centimeter, and when the water from falling from the h1 to h2, so it takes time, let us say time is equal to 120 seconds. Then if you can calculate log h1 by h2, because h1 is known, h2 is known, that means log of 50 divided by 46.5. So, this you can, if you can calculate, this will give 3.152 into 10 to the power minus 2. So, you know that this log h1 h2, you know the time, and then you can calculate that what will be the coefficient of permeability of the soil using this equation, that is k is equal to 2.303 a into L divided by a into t log h1 by h2. You know from here what is log h1 by h2. So, this value is known. You know the time, elapsed time is required, this time you know the final and initial and final height. So, you know this, and this is constant cross section area of the standpipe. This is cross section area of the standpipe is known, A length of the sample is known, A cross section area of the mold sample also it is known. So, knowing this, you can calculate that what will be the coefficient of permeability. Let us say that coefficient of permeability of the soil for the serial number 1, for the serial number 1. I am showing you 1, that is K is equal to 2.303 A into L, this divided by A into T into log of 10 H1 divided by H2. So, this is 2.303 into, that is small a, that is cross sectional area of the standpipe. That means these values, cross section area of the standpipe A, that is 0.6648 quarts diameter. So, this you can write small a is equal to 0.666648. This into the L. L is the length of the mold, that sample is 6 centimeter. So, L will be equal to the 6. This divided by A. This is A, that means this is the cross sectional area of the sample, and this cross sectional area of the sample also is given. This is cross section area of the sample A is 50. Okay? This is 50 square meter. So, this will be the cross section area 50. And I say from this that time required is 120. So, this is 120 seconds. So, this into log H1 divided by H2. That means log of that initial height H1 is the 50. So, this is 50. This divided by H2 is 46.5. This is 50. So, you can calculate this and you can determine the coefficient of permeability. Let us say 4.8254. If you calculate, it will 10 to the power minus 5. This is centimeter per second, and that means you can write down 4.8254 into 10 to the power minus 7 meter per second. So, you can calculate the coefficient of permeability of the sample for the variable head test method, and this coefficient of permeability value you can see 4.825 into 10 to the minus 7, because it is a clay type of the soil. You can see earlier that coefficient of permeability is 10 to the power minus 5, maybe the sand sealed, but in clay this coefficient of permeability is about 10 to the power minus 7 meter per second. So, you can now calculate that coefficient of permeability for the variable head method and the constant head method, and this parameter is very, very important to us, because this parameter we can use for any drainage and any kind of the filtration problem and the gradation of the soil and coefficient of permeability of the soil. And you should obey the Darcy's law, Q is equal to K into I into A, whether it is in a laminar flow condition or it is in a terminal flow condition, and accordingly you are to calculate the coefficient of permeability of the soil. So, different types of the soil, it may be the gravel, silt, clay, sand. So, these coefficient of permeability also vary from soil to soil. So, one has to be select proper kind of the coefficient of permeability, whether it is for the permeable purpose or whether it is the impermeable purpose. For example, if you use for the landfill, where we use sometimes compacted clay liner, so it is a impermeable. So, you need the more impermeable. So, that value it may be helpful here, that 4.825 10 to the power minus 7 meter per second will be the more important value for the compacted clay liner, what you can use for the construction of the landfill. Or apart from that, you have to go for the landfill, let us say about 400 to 2500 or 3000 millimeter the thickness of the compacted clay liner, but nowadays some alternative geomembrane has come which thickness is maybe the hardly that 1 or 1.5 or 2 millimeter thickness, alternative to the 200, 500 or 3000 millimeter of compacted clay liner, and that also as an impermeable material. So, here we are restricted for the clay for the variable for this variable head method, how you can calculate the coefficient of permeability of the clay, and the constant head permeability, how you can calculate the coefficient of permeability, let us say like a sand, okay, or you require for the proper kind of the drainage system. That is why we use for the sanding, that in order that drainage can be very faster, and it depends upon the value of coefficient of permeability, where the excess pore water pressure can develop and the water can be permeable very faster. Of course, there are some alternative systems like the sanding, that alternative system like PVD, prefabricated particle drain, which will give much higher coefficient of permeability than the sand, and in order that you can consolidate the soil very faster, and acceleration is very fast. You are not to wait for the long time to consolidate it. So, within a short period of span you can complete the consolidation with some alternative system. So, that was the reason that it is very important to understand that coefficient of permeability for different types of the soil, either it is a constant head method or it is a variable head method. Now, we will discuss the shear strength test. This is another very important parameter, shear strength of the soil, and you should know how to perform the shear strength of the soil. Here also different types of the soil, it may be the clay, it may be the sand, it may be the gravel, it may be the silt, and how to calculate the shear strength. This is a very important parameter in the geotechnical engineering. And the shear strength of the soil or shear strength parameters is very important. So, our here is the main objective is to determine the shear strength of the soil sample. There are different methods in which you can calculate the shear strength of the soil. One is the direct shear test method, and this also small scale direct shear test or the large scale direct shear test you can perform, and sometimes nowadays you require for the large scale direct shear test method, because if you wanted to determine the shear strength parameter of the gravel, okay, which you may not be accommodated in a small scale direct shear test, you require large scale direct shear test value. Even then we have some 1 meter by 1 meter direct shear test, very large scale direct shear test, in which you can calculate that what will be the shear strength and shear strength parameter of the soil. Apart from the direct shear test, also you can calculate this shear strength and the shear strength parameter of the soil by the track shear test and the unconfined compression strength test. So, what is the shearing strength? The shearing strength is the property which enables the soil to maintain equilibrium on a sliding surface. So, shear strength of the soil consists basically of the two components. So, one component is the friction, one component is the friction, okay, which is dependent on the internal friction between the soil grain. So, it is important that what would be the internal friction between the soil grain. So, one parameter is very important, that is what is called the friction. This is important. And second parameter is called the cohesion. So, these are the two parameters is important to us, and which you have to determine that what will be the shearing resistance of the soil or friction of the soil, and friction of the soil is sometimes designated by pi and the cohesion is designated at C. So, you have to calculate what will be the shear strength and the shear strength parameter of the soil. So, shear strength parameter is the C and the pi, and C is the cohesion, and a cohesion which is influenced by the grain size and the state of packing of the soil particle and the water content. So, these two parameter that is Coulomb's law, we call the Coulomb's law. Coulomb's law. So, this is the S is equal to C plus sigma n into tan of pi. So, Coulomb developed this law, that means shear strength of the soil is equal to the cohesion, that is C, plus the angle of internal friction, that is pi, for a particular normal load sigma n, where S is shearing strength of soil and is expressed as kg per centimeter square, and C is equal to cohesion intercept, and that also expressed as kg per centimeter square, and sigma n is the pressure normal to shearing plane, and pi is equal to angle of shearing resistance, angle of shearing resistance, and that shearing resistance of soil, and that also can be expressed as degree. So, this shear strength parameter also sometimes that depend on what type of the soil. If it is a cohesive soil, if it is a cohesionless soil, or if it is a both cohesionless soil and the cohesive soil, and then how you can calculate the what will be the shear strength parameter of the soil. So, if it is a, you have to determine what will be the normal stress and the shear stress, and then you can draw from the Mohr circle diagram what would be the shear strength of the soil. So, you know that what is the normal stress, you know that what will be the shear stress, then you can calculate that what will be the angle of friction pi, or what will be the cohesion value. So, that you can only calculate it based on this Mohr Coulomb criteria, and from that equation you can calculate. So, if it is a let us say that if it is absolutely that cohesive soil, then line will be like this, where there is a pi is equal to the 0, Okay. This is absolutely purely clay type of the soil. Or if it is the, let us say, sand, then it will be give only that pi value. Okay. There is no C value, no cohesion value, only you can have some pi value, 30 degree, 35 degree, whatever it may be. If it is the cohesionless soil or sand, if it is a cohesive soil, so you can have what will be the cohesive value here, C. So pi is 0. When if it is a cohesionless soil, so you are having the pi, but C is 0. Or if it is a both the friction and cohesion, so you can have this pi value and you can have the C value, and this also called C and pi soil. So from this also you can calculate that what will be the cohesion value and what will be the angle of shearing resistance of the soil. This is called the C pi soil, because there is a cohesion and angle of internal friction. So this is what we will study in detail by the shear strength parameter, how we can determine. As I told, for different types of the diagram you can draw for the different types of the soil. If it is a cohesive soil, if it is a cohesionless soil, or it is a both the cohesive and cohesionless soil, then you can see how we can draw the Moore Coulomb failure envelope and how we can determine that pi value, angle of shearing resistance of the soil, and cohesion of the soil. These are the two parameters is very, very important in for the soil mechanics or the geotechnical engineering. So you should know how to perform the test. Next time we can go detail about this, and thank you.